name is Cassandra Calderella, and before I get started with my presentation, I would like to thank the Graduate School of Arts and Sciences for taking the time to consider my application for admission. My goals and objectives in obtaining a Ph.D. from mathematics or atmosphere ocean sciences is to be able to conduct groundbreaking research in this field. I would also like to be able to represent groups that do not get as much recognition in this field, such as minorities and females, since I am both. I have always excelled in math and science. During my undergraduate studies, I took a graduate level course in thermodynamics, and I graduated a semester early because of AP credits that I obtained in high school. I am a hard worker, as well as a quick learner and task-oriented, and I am always up for a challenge. One of my favorite subjects in math is using the dot product and line integrals to be able to determine the work done on a particle. Today, the problem that I will be solving is as follows. Let F be a constant unit force parallel to the vector -1, 0, 1 in xyz space. What is the work done on a particle that moves along the path of t, t squared, and t cubed between time t equals 0 and time t equals 1? We will begin with the equation work equals the integral from t naught to t1 of f dot r prime dt. The variables are as follows. F, the force, is equal to -1, 0, and 1. RT, the path, is equal to t, t squared, and t cubed. T naught equals 0, t1 equals 1. We will need the derivative of this path, which is equal to 1, 2t, 3t squared. Now that we have all the variables, we can plug them into the equation as follows. And when we do that, we will have w is equal to the integral from 0 to 1 of -1, 0, 1, dot 1, 2t, 3t squared, dt. Now, from this, we will use the dot product in order to solve this, and we will get the integral from 0 to 1 of -1 plus 0 plus 3t squared dt. Now we can integrate this into something more simple, and from there we will get -t plus 0 plus 3t cubed over 3. We can cross out these two 3's, and we will be left with t cubed as the last problem. From here, now we can substitute in 0 and 1 for t, and when we do that, we will have -1 plus 0 plus 1 cubed minus 0 plus 0 plus 0 cubed. This turns out to be 0, and once we do the math from here, we will have -1 plus 0 plus 1, and this will also turn out to be 0. And when we subtract this, we have 0, which means that there was no work done on this particle in this force. From here, this shows my understanding of the dot product and line integrals as very important to vector calculus, since this is a way to find the work done from a mathematical point of view. Thank you very much for your time.